Do want to see if this works. Want to see if this works. Want to see if this works. Okay, perfect. I also hope you guys can hear the music on Twitch. Awesome. Okay. It's all good. All right. I'm gonna be redoing the platformer that we were working on earlier. Should be a lot quicker now, and hopefully by the end of the stream we'll be caught up with what we had from the last two streams, plus some extra states, and hopefully it'll also be slightly cleaner. But yeah, let's get on with it. I'll also be uploading this onto YouTube. Hopefully I'll trim it all down by tomorrow, and I'll upload the GitHub repo and everything. I've already created the repo, so hopefully, I'll just post it, and then I'll automatically have the link in the description. But yeah. So let's get on with starting up our other projects. I'm gonna open it up just so we have some sort of reference. And I'll probably also open up memory so we have something to look back on, to make sure we're replicating the the correct mechanics. But yeah, let's just open this up again, and first we'll create the player. Go into 2D and make a character 2D. We'll add a collision shape here. And I'll just make it a square for now. And next we'll make all of our states. I'm going to make a node as our state manager. We'll just call this states. And then inside we'll keep adding more node 2Ds for each state. So for now, actually what I think I'm going to do is I'm going to make a new scene here. Make a node. And then in here, I'll call this idle. Let's make a new folder called player. Actually, we'll make a new folder called scenes. And in scenes, we'll make an entity. And then in entities, we'll make player. And then in player, we'll add the idle state. And I think, yeah, we can leave it like this. Idle, and we'll make a script called idle. And then all I'm gonna do here is duplicate a bunch of these for every single state that we want. So we'll do 3 for now. We'll do idle, jump, and fall. No, idle, jump, move, and fall. We'll do 4. So let's duplicate this one. I'm gonna capitalize it. And another thing that I want to do before we actually create all these states is in our script here, I'm actually going to make this extend a state class. So let's make a new scene here. Oops. It just needs to be a script, actually. So we could go into here, make a new script, and we'll call it state.gd. And we'll put it in the player. And create. And then we'll have this extend states .gd. Oh wait, no. Oops. This should extend node, and then everything else will extend. Wait a second. What's going on here? Oh, state.gd is saved. Okay. For this node, we'll save move and add a move script. Okay. Move.gd, and we have our move.tscn. Okay. Move, jump, idle, and we'll make one more. The fall state. And I'll just duplicate this one. Go into fall, we'll rename this to fall. Remove the script, add the script again, add a false script. Okay, and in all of these states here, we want to make sure that they extend states.gd. Okay. Follow, move, let's jump. Oh, let's make sure we save this too. There we go. All right, and in our states for our player, we'll just throw each of these scenes in. So we've got our fall, we've got, why didn't this one save? Let me delete it again. There we go. Fall, idle, jump, and move. I'll just make sure this gets renamed here. Okay, I'll call this player. Okay, and we'll make a states script. This is what actually, it seems like I haven't been using this in our player script. Usually what I do is I just have our states communicate with the player node. I don't see any problem with this, and it's because, like, if we have our player communicate with the states, it's just a lot easier than having our states communicate with the states node and then having the states node communicate with the player. So honestly, I think if we can avoid adding a script to the states node, we just might. Unless like somewhere down the line we find that having the state script is beneficial. I think what we usually do is just have all of our states written down here, just like, I guess, for like organization purposes, but for the most part it's not too important. Honestly, we could even throw this into the player and call it a day, but we'll put it into our states so it's cleaner. So leave this the way it is. We'll throw all of these in here, and we'll get rid of this code here. And we're gonna add a player script. And I think we'll get rid of the physics process here. We're just gonna rewrite everything. So let's erase that. All right, I think we're all set up. I guess we can start making some movement here. And another thing I'm gonna do real quick is just make a super easy tilemap, just so that we could test out our rooms. So I'm gonna put this in scenes, make a new folder called environment. We'll call this test tilemap. Okay. And for now, we'll use the Godot icon as one of our textures. So let's make a new tile set here. Throw this in here. Would you like to automatically create tiles in the atlas? Sure. Alright. So if I remember correctly, we have to go into physics layers, add an element. This is good the way it is. And then in... where is it? I thought it was in here, but let's see. Now there's something else that we have to do. Oh, there we go. Patterns. No, paint. Select the physics layer here, and we'll just add it to everything. Yeah, eventually we'll want to make this into our own bit mask. Or like, yeah, our own auto tile. But I don't think we're going to do that today because it's just not important yet. So we'll make a simple room. Usually I like to keep our resolution at like, what was it, 320? Something like that. And I'll add some extra tiles here just so that we could test out some of our states that we're going to be working on. So we're going to, you know, obviously we have the idle state, we have the move state, we have the climb state, jump state, slide state. So actually, you know, we'll put our player here, that way they can jump or go from the idle state or the move state into the fall state. And next thing I'm going to do is just make a new scene, and we'll call this world. And this is where we'll put our player in. And where we'll put our tile map. After our player here, let's add a texture to our player. For now, it's just going to be the icon, the Godot icon. But we might make the animation player today as well, if we can power through this. Alright. Throw it up here for now. And let's make this 8x8. Alright, and in our player code, we're gonna have to make some movement functions, and I think we learned that it's probably best not to put it in our player code, but rather into each of our states. So we're gonna have some sort of movement function in our state here. So let's call this func player movement. And what we'll put into here is we'll grab whatever our player movement is. So we'll go back into our player now, and we're gonna make a function called player input. And for now, let's make some new buttons in our input map. We'll say move right. Yeah, we'll capitalize it. Move _ right. Actually, now let's do that. Move right. Move _ left. Oops. down. Actually, I kind of like it without the underscores. Move right, move left, move down, and move up. We're also going to have a dash, and we're going to have a climb, and we're going to have a jump. So for now, we'll set this move right to D, our move left to A, our move down to S, move up to W. Dash we could put as F, climb we could put as C, and jump we'll put on space. And actually, it really depends on what you want to use. Like, usually I'll use a controller, but since we're just testing out mechanics for now, we'll just leave it like this. I will also include the arrow keys for our movement. So for move right, it's going to be right arrow key, move left, left arrow key, down, down arrow key, up, up arrow key, dash, we will put on X, and jump. Jump, I guess we could put as Z. And C we can leave the same. Yeah, that's pretty good. Okay. So what we're gonna put in our player function for now is if input dot is action pressed, we'll include move right. And what I'm going to do here is actually have another variable called movement. I think we're going to call it movement input. Movement input is equal to a vector 2. And what we'll do here is for every player input, we'll be resetting the movement input. So we'll say movement input is equal to vector 2, 0. And we'll set movement input dot x to plus equals 1. And then we're going to do the same. Oh, this is a slightly annoying with the new Godot 4 that it automatically selects a random value here, or a random variable here. I'll have to figure out what's going on with that. I don't know, maybe there's like a setting that I have checked. But yeah. So we'll do the same thing except for move left input. But instead, we'll subtract. Hey man, it's so much harder to make a live stream than standing in front of a class. Really? You think so? I would assume... I guess I don't know. But I would have assumed teaching in front of a class was harder. Because at least with an online stream, you can't tell what people are doing, right? I mean, you can't tell how people are reacting, you know? Like, I'm talking to a screen right now. The next thing I want to do is move up input. And we will subtract here. And then one final thing is the move down input. And we want to add here. All right. The other input that we want, there are a few more inputs that we want to account for. One of them being var jump input. It's equal to false. And we also want jump input actuation. And I'll explain why we need this later on. Or why we need both jump input and jump input actuation. Alright, another input that we're gonna need is the climb input. I'm actually gonna call it climb. Yeah, climb input here. I can see if they understand or if I should explain it in more details. Oh yeah, I guess that makes sense. I guess I'm not really teaching as much on stream. It's kind of like people just watch me code. Although today I'm trying to convert this to a YouTube video. So I'm gonna clip out all of the parts of like me talking to people. Hopefully, I hope it doesn't take this much work. Where yeah, I'm gonna clip out most of the video of like me just talking to you guys, and then when I'm explaining what I'm doing in the code. That's what'll be on the video. So if I sometimes ignore your comment just to finish up the code, I apologize. But also, hey, how's it going, Mr. Glick? All right, so we'll do, and basically all I'm doing is repeating what we did in the last stream, but I think it's going to be a lot more organized, a lot more descriptive, and a lot more, organized. I think that's basically. Oh, I forgot to ping Discord. My bad. Yeah, let's do that now. Okay. Here with my new keyboard. Nice. Alright, let's finish this player input function really quick. We also might update this in a different way later on, but I feel like so far this has been the best approach for handling like responsive movement or responsive input. But yeah, we'll see. Alright, what do we need? Jump input. So if input dot is action just pressed, not action pressed but just pressed, we'll grab the jump input, we'll say jump, and then we'll say jump input actuation is equal to true, else it's going to be false. And here I'm going to put jumps. I typically don't comment in my code. It's probably something that I should be, more consistent with. But I think it's because like I like to be very descriptive with like my variable names. But since I'll be posting this online, I think having comments is probably a good idea. Will I put this footage onto YouTube? Yeah, that's the plan. I plan on like splicing, all the parts of me actually talking into the video rather than, me talking to you guys. I don't do that. Yeah, I don't know if it's pretty subjective, right? Like, I haven't had any issues with not commenting, but I know people that like swear by it. But yeah, since people are gonna be reading this stuff and maybe they're not used to how I code, it's probably a good idea. Yeah. So we'll do if input. So this is gonna be the same exact thing, but only checking for action pressed. If input dot is action pressed for our jump. Oops. And I just realized we could probably throw this into here and then check for just pressed, but we'll leave it separate for now. Jump input is equal to true, and let's also make sure this is false. Jump input is true, else jump input is false. If I need a good thumbnail, hit you up. All right, sounds good. Thank you. Have I thought about the background music? So I was thinking of not having any background music. I've already disabled it. So I'm currently recording this stream, and on the music track or like on the audio output, like at the moment, there's no audio. I don't plan on adding audio during this tutorial. So yeah, I might have some like looping music or like, yeah, some music in the background that I add, after I'm done, putting all the clips together, but yeah, at the moment it's just gonna be quiet. And you guys will also be on the YouTube video, I guess. I didn't think about that, but yeah, the the thing on the bottom left here. I mean, bottom right will be visible on stream. Or are you recording it at the same time? At the same time, instead of using the stream itself for footage? Yeah, that's what I'm doing. I could just grab the stream, but I thought maybe the quality would be better if I just record it simultaneously. I'm not sure yet. We'll see. We'll see how it goes. Okay, and we'll need our climb state as well. So, climb input. I think you can add music separately. Yeah, I think that's probably what I will do. Okay. You know, I also just realized that our stream is like slightly lower. Yeah, let me see if I could lift it. Yeah, our screen is actually, I don't know if it's stretched. What's going on here? Oh yeah, there we go. Would I make a goofy face for the thumbnail? Yeah, sure. Like, oh my god, I'm so surprised that that this works. Or what? Godot 4 is out? 5 simple steps to make a game and become a millionaire? Alright, let's finish this up. Input. So we'll say if input dot is action, and this is going to be pressed. We'll grab a climb, and we'll say climb input is equal to true, else climb input is equal to false. And I just realized maybe what we could do instead of having these else statements is just reset some of these values. So like jump input actuation, we could just set to false right here all the time instead of running this else statement. I think that's actually probably a better idea. I don't know if it's gonna be well, actually, you know what I think I'll do? I'll leave it the way it is right now, but if we wanna, I think if we wanted to optimize it, we would just throw all of these in here. Because it's better to just set the value of the variable than to check for something and then set it. I always laugh when I see those, oh my god, you don't believe what happens next, or surprise face thumbnails. You know what annoys me the most? Like, out of all of those videos, the ones that like they bait you into watching the video for a long time. They're like, oh, you won't believe what happens next. Wait until the end, and like they just keep dragging it on and on and on for like 10 minutes, and it frustrates me. I purposefully, dislike those videos. All right. So we have our climb input, and one more input that we need is the var dash input. Set this to false. And let's just put player input here. Okay. And let's just copy and paste this. We'll say var dash and throw all of this in here. Dash inputs equal to true, dash inputs equal to false. If they fooled you twice, it's you're to blame. Yeah, to be honest, I've fallen for it many times. So yeah, fool me, 6 times. Shame on me, or shame on me for the first 6 times. But at least I learned my lesson. Fool you once, it's your fault. Fool you twice, you're to blame. Yeah. I think we're missing something there. Okay. So this is all of our movement. We're also gonna have well, our player deals with the velocity, but that's a built-in variable, so it doesn't matter too much. Oh, and it automatically sets our up direction to -1. That's pretty cool. By the way, in like 2D physics, usually negative goes up and positive goes down. So, whenever we say, whenever we're referring to the up direction, so you can see here, move up is actually equal to -1. That's just something important to remember. So what we'll do now is we'll actually put this in our physics process. So we'll say func physics, we can spell, physics process, and we'll run player input in here. Player input. And we're also going to run states.update. We're going to have to add this to our states here. Oh, not to our states, but to our state script. Let's go into our player state script, and we will say, instead of function, we're going to say func update this, and then by default, it'll return null. Godot is Python, but easier. Godot is, well, yeah, GD script is Python. And I don't know if it's easier. I guess it's all relative. If you're used to game development, then I would say it's easier. Mix of GD script and C++ or only GD? Yep, Godot, or yeah, so GD script is a language and it's similar to Python. Godot is an open source engine, and you can use, I mean, you can use GD script, which is, the language used by Godot, or I'm sorry, the language that the developers of Godot created, or you can use C#, or you can use, technically you can use C++ if you wanted to. If you wanted to mess with the engine itself. And I think some people mentioned that you can use Rust, but I haven't heard much about it. But yeah, Godot is the engine, GD script is the language that I'm using. Okay. So in update, what we're gonna do here, well, yeah, by default it's set to null, but what we're gonna do in each of our states is we're gonna check for what sort of input is happening. So let's say we're in our idle state. Let's get rid of this. Let's get rid of all of this. We'll say func update delta, and what we'll put in here is if move input, or sorry, we also need a reference to our player. So let's go back into our state script, and in our ready function, well, actually, no, over here in our variables, we're going to call var player is equal to null, and in our ready function, or actually no, in our player function, in our player ready function, we're going to iterate through our states and make sure that we set the player node, player reference node, we set the player reference node appropriately. So what we're going to do here is we're going to say for state in, we could say in states dot get children. We're also going to be creating a reference for our state, so we can also say on ready var, if I can spell correctly, states dot, or states is equal to $ states, and then we can just put states in here. And then for each state, we want to make sure that we're creating the appropriate state. So we will say, well, actually, no, for this one, we're going to make sure that our reference to the player is correct. So we'll say state.player is equal to self. What else do we want to do? Here, let me look at our old script here. Okay, and we also want to make sure that we have a reference to our states. So we're gonna say state dot states is equal to states. It's a little confusing. Basically, we're just making sure that each of our states has a reference to its parent. So the fall state knows that its parent is the state's node here. And the reason why we're doing it this way and not by writing like get parent or writing $ states is so that it's just slightly more efficient than having us search for the node every time we need a reference to it. So we just do it at the ready function and then never have to worry about it again. But let's make sure we have the variable for this. So I'll say var states is equal to null. Is any one of you joining the game jam that NPC is hosting? I'm currently making a little program where we can make music for ourselves and build in sounds, or make the program create a track itself for you. Free to use whatever you like. Awesome. Yeah. I wish I was better with making music because I would love to use these programs. Like usually, like the only program that I've used in the past was Bosca and 1-Bit Dragon, but I feel like I'm never satisfied with the sounds I make. Is ready equivalent to the start function in Unity, aka when you start and add the object to the scene? Yeah, so the ready function is basically what runs when the object, after the object gets instanced as I believe it's instanced as a child of like an object. So once you add it as a child of an object and it's in the tree, the ready function will run. Or does it run on the... Yeah, I'm pretty sure when you add it as a child, that's when it runs. We could double check. Surely everything is a child of the scene. Not necessarily. Like you can add an object, you can create an instance of an object, but not have it in the scene. So like, yeah, I don't have any examples of it here, but yeah. Like when you create something, you first instance it and then you have to add it. Okay, let's finish up with, what were we doing? States. Okay, so we have all our references set up. Let me just make sure. We do have an animation player that we want to reference as well, but I'll save that for later. Right now, what we'll do in our idle update is we'll check if our movement has changed. So if player.move input, is that what we called it? Let me make sure. Movement input. Okay. Movement input does not equal, or .x does not equal 0. Then we'll say, we'll basically tell it to move right. Or actually, what we'll say is go into the move state. So we'll say return states.move. Oh my god. And that's it. Else we'll have it return null. And I mean, this is the only state that we need to be worried about right now. Actually, we'll add the jump state as well. So if, also what's going on here? Player is not declared in current scope. Okay, never mind. If player dot jump input, jump input actuation is equal to true, then we will return the jump state. What other states do we need to be concerned with? What's going on here? Players not declared. Oh, there should be state.gd. Make sure you put the update delta function in here. This is why I use Unity over Godot. I mean, it's the same thing. Like, I'm pretty sure Godot has the same thing. Where Unity has the same thing. Where if you wanted to create an object, you still have to add it as a scene, or like add it as a child of something. It's a very, like, you know, if you create a scene, like, you know, for example, we have this scene right here. Whatever objects you put into the scene are already there. But if you want to add something via the script, then that's a different story. Okay, what is next? Let's see. We have all our states here. We didn't actually create all of them. So like the dash, or yeah, let's see. We have 1, 2, 3, 4. Some of these, I don't think it'll give us an error if we run this. Let's see. Yeah, it will give us, it will say that some of these states don't exist, like dash, slide, and climb, but that's fine for now. It'll still run. And we will do it by the end of this stream, I hope. Let me throw this here. And nothing works yet. Let's make some gravity. We'll say func. And I wonder, where should we run this? We could run this in the state script. But I think it's appropriate to put it in the player script. So we'll say func gravity. Let's throw delta in here. But we will be running this from our states. So fall will run gravity, idle will run gravity, jump and move will all run gravity. Let me just do one more thing. We're gonna grab some other values from my old project, and this is just to make some of our jumps more consistent. What I do here is we set our tile size, we set the spring, we'll ignore this for now actually. The spring, we'll just grab our max jump height, our min jump height, our jump duration, and a bunch of these variables for determining what our velocity is going to be. So I'm gonna copy all of this and throw this into, we'll call this player physics. And throw all of this in here. And then in our ready function, or actually we'll make a new function for this. We'll call this func determine velocity. And in determine velocity, let's just grab the exact code for this, because I don't remember what it was. Oh, set velocity values is what we'll call it. Just throw all of this in here. And I don't remember what the math behind it is. Just trust that it works. Basically what we want is we're going to determine what our gravity is based on our jump duration, what we want our jump duration to be. So right now I have it set to 0.3 seconds. And then this is what helps us set our max. So like if we want our max jump height to be 8 times 3 pixels plus some extra offset for jumping above those tiles, this is what we this is the code that we write. But yeah, if you want like I could probably do another YouTube video on explaining this, but I actually found this from a YouTube video, so maybe I could find a link for it instead. But yeah, let's set this to gravity var. Let's set this to 0 for now. Spring velocity. I'm gonna comment this out for now. We do eventually want to have some sort of spring velocity, but I won't set it up just yet. And in our ready function, we'll just say determine velocity, or here, let's call it set velocity. Set velocity values. Could you see GameMaker is not that different from Godot? I just hate that I don't have the events in Godot. You need to make those scripts yourself. I see. Yeah, it was very similar. Like it seemed like I knew everything you were doing while you were coding. But I feel like that's with most programming languages, or I guess with most like game development programming languages. Or I guess with C#, because I feel like that's what most engines use. Okay, set velocity values, and let's just run that here. Set velocity values. Okay, and that's that. And in our physics process, we're going to run change state. We haven't written anything to handle our states just yet. We still haven't had like any physics on the player yet. We're just setting up our state machines, but it'll happen pretty soon. So let's do func change state and run input state as an argument. And what we'll do here is if input state, here, let me scroll down a bit. Basically what we'll say is if input state does not equal null, we'll change the state to whatever we need to. Let's also create another variable. Call this section states. And let's grab var current state is equal to null. And we also want to reference to our previous state. We'll say prev state is equal to null. And what we'll do here is we'll say current state is equal to input state. But before we do that, we'll say previous state is equal to our current state. And eventually what we want to do is also make sure that we're running current state.enter state. And we'll just do that now. Current state.enter state. And previous state. Before we enter this state, we actually want to do previous state.exit state. And let's just make sure we're putting that into our script, our state script. We'll just say exit state. And func enter state. You code in a way that I just love. I get some nice little tricks from time to time. Thank you, I appreciate it. I will say that I've gotten better over time. It's not like I feel like some of my practices were pretty messy to begin with, but yeah, you learn along the way. You look at other people's scripts. You also get sometimes people that like criticize your programming, and then you're like, damn, maybe I should fix what I'm doing. Especially in like the programming community, or like I mean, I guess because programming is very similar to game dev. Or I mean, like, there are a lot of programmers in the game dev community that you're going to get a lot of people that criticize you. AKA you. No, you're not really critical, I would say. Like, yeah, those I think everyone's experienced like pretentious programmers that are like just, they think they're better than you or something like that. me not liking that's something that's super like insignificant. I mean, like, I don't know. I'm trying to think of like a good example. It usually doesn't happen, but you do get those types of viewers from time to time. You coding is trash. Your coding is trash. Your typing is trash. If your typing is trash, I don't even know. I don't even want to look at your coding. You type slowly. Yeah, I think everyone's met those types of programmers. Like, it's everywhere. Okay. Okay. So yeah, we have our change states here. Now let's make sure that we're running physics on all of our states. So in our idle state, we're not really doing much. We're just checking for let's see here. For movement and if we're jumping. And that's all we're gonna do in this state. Then we'll go into the move state. So if the player movement.x does not equal 0, we'll go into the move state. And what we'll do in the, here, let's get rid of all of this. Func update delta. We shall run a player movement function, which I think we already introduced into our state script, right? Yeah, player movement. Okay. So in player movement, let's go back to that. We're going to say player dot velocity is equal to our move input, or actually player.velocity.x is equal to our move input, is equal to our player dot movement input dot x, and then times some sort of speed. And I think what we do is we have player dot speed. Let me just make sure. We have player physics, player states. Let's have another section here, and we'll call it player movement. Actually, we'll put it in player physics. Say var speed is equal to, let's say, I don't know, 100? No, let's do 50. And then in our move state, we'll say player.velocity.x is equal to player.movement_input.x times our player.speed times delta. And we'll just have to make sure that we actually put delta in here. Oops. Actually, do we even need delta? I'm pretty sure move and slide already handles delta. Let me just make sure. Oh, we shouldn't have erased that code. Let me just look at our test here. Look at states, player movement. Yeah, we don't multiply delta, so I just leave it like that. All right. What is next? Speed is equal to 50. So in our move speed, let's get rid of delta, and in our state, should work. So let's run this. Finally, we're actually testing something out and watch it not work. Let's see, player.speed, identifier player. Yeah, let's make sure this is capital. And run it. Let's also add a camera to our player for now. So let's create a camera 2D, And we're gonna zoom in a bit. Let's set this to 2. All right, and let's run our world. So nothing happens just yet, and that's because in our move state we didn't actually run this in update. So let's run player movement. Let's see, player velocity.x is equal to player movement.x. In our player, in our physics process, we have player state. We don't actually have anything returning or changing the state of the player just yet. So let's do that. So what we'll say is we're gonna run change state on current state. Dot update of delta. So basically what's happening here, in a nutshell, we're running current, we actually don't have a reference to our current state yet, but our current state is going to be one of these nodes here. And what we're doing is running update on each of them. So if we go into here, you'll see, well, not in this one, but if we go into our idle or into our move state, we have this this update function running. And so let's say we're in the idle state. We're going to be running update consistently on idle, and it's going to check for player input. If player input does not equal 0, basically if there's some sort of input, we're returning states.move. So what's going to happen is when we return states.move, it's going to go through this, and it's going to say, basically our input state is not null. We're going to exit our idle state and enter the move state. We don't really have anything in our enter or exit states yet, but it's going to be pretty important later on. Why don't you just import default gravity? The reason why I don't want to import default gravity is because we want to be able to control our jump durations and our max jump heights and certain velocities. And we use this function to do so. If we used default gravity, then we would have to manipulate certain values. We would have to keep testing it to see what would be the perfect value to get a perfect jump height or a perfect jump distance or something like that, which is kind of annoying. You could do it, but if you're making a precision platformer, you should probably make your values more, I don't know, I guess, I don't think consistent is the right word, but you want to set an actual value to your jumps rather than just putting in a random value and hoping it works. Or not a random value, but 980 or 9.80, whatever the default gravity is in Godot. Okay, so we're running change state. I hope this works. We don't have gravity on the game just yet, but we'll do that next. Let me see here, non-existent function, update and base nil. Okay, so what we have to do as well is in our ready function, let's make sure that our current state is set to something. We'll say current state and previous state we'll set to something. So current state is equal to states.idle, and current state, we'll set them both to idle, and we'll say previous state is equal to states.idle. It's not really important what it's set to, because it's going to change almost immediately. So let's run it again. So yeah, there's still no gravity on the player. And actually there's no move input on the player either. Let me see. Change state, current state, if change state, exit state, current state, dot input is equal to our input state. Let's see. Here, let's do this. I'm gonna add a label to our player just so that you guys can see it. And we'll just have it hover over the player. Let's say just like that. And we'll just say label dot text is equal to str of our current state dot get name, and run it. Okay, so our current state is idle, and then we are in the move state, but nothing is currently happening. So let's go back into our move state, and let's see why it's not working. Player.velocity.x is set to our move input.x times x. Move input.x. Times player speed. Oh, of course. We don't actually have move and slide in our physics process yet, so let's just do that. Move and slide. And there we go. So now we can move left and right. And here, let me zoom in on the player just a bit. Just joined Saltoon's stream as he handed. Oh, damn. But yeah. Here is our move state. There's no gravity just yet, and we'll do that now. So, and another thing that we want to do is also make sure that we are returning to the idle state if we're not moving. So what we'll say is if, but in this case, we're actually going to check if the player's velocity is equal to 0, rather than checking for movement. And that's because there will be some sort of delay when it comes from the player moving into the going from the move state into the idle state. So we'll say if player dot velocity dot x is equal to 0, we will return states dot idle. And we'll also return states dot fall. Oh, return states dot null. Or return null. And what we'll do here is also check for the fall state. So if state or if player dot velocity dot y is greater than 0, then we're going to return states dot fall. If I can spell, turn states dot fall. Okay. What's going on here? Player. Let's make sure this is capital. Okay. And another technical issue is that we can go into the idle state before we go into the fall state. So what we'll do, I think that's fine, but we do want to make sure that we go into the fall state from the idle state. So we'll say here, if player.velocity.y is greater than 0, we'll also go into the fall state. And I think it's actually more, since I don't think this will happen too often from our move state, going to the idle state is probably the most common. Or going into the jump state or some other state that's not the fall state. Wait, actually, no. Going into the fall state is pretty common. Going into the fall state from the idle state is not common. So I'll actually throw this above. I think this kind of ensures that we'll go into the fall state first, almost all the time. Okay. What is next? We're also gonna just start throwing in states here. Some of them won't work, like the fall state won't work just yet, but we'll throw them in. So yeah, we have the fall state. And we'll throw in the jump state as well. So if player dot jump input actuation another thing that we want to do is check if the player can jump. So what we're going to do here, this is from the move state. Actually, it's fine this way because the player will always be able to jump from the move state. But when it comes to the fall state, that's when it's going to get a little bit more concerning. But we'll handle that pretty soon. So if jump input actuation is true, we return the jump state, and we're going to do the same exact thing for the idle state. Okay. And we'll also do the same exact thing for the fall state, but there's going to be a few more if statements, or just like one more variable checking for something. So we'll do func update delta, and we'll throw this in here so we don't have to worry about it anymore. And in our jump state, let's also throw func update. And let's start adding gravity. So what we're going to do in our physics, not in our physics process, in our player state, or in our player class, we're going to say velocity. Can you guys see? Yeah. Velocity dot y plus equals our gravity var times delta. But we're not going to run it in our physics process. We're going to run it in each of our states that, in each of the states that we find appropriate. So that's going to be in the idle state. Actually, there's one more if statement that we're going to put in here, and that's if is on ground, or is on floor. If not is on floor, we'll run gravity. And then in our idle state, on the top of our update, we're going to say player dot gravity delta, and that's it. So player movement in our fall state, in our jump state, and we'll also run player movement here too. In our jump state and in our fall state. Okay. What else? What else? What else? Player movement. We don't technically need player movement in our idle state because our player is already checking for input. So yeah, it's not really a concern. All right. Let's see if this works. So yeah, now we have gravity. And just like that, gravity works. Oh, but there is an issue. We're not able to move at the moment. Let me see what's going on. Velocity.y is equal to gravity var. Let me print out our velocity here. Okay. In our idle state, if velocity is greater than 0, we enter the fall state. Let's see. Yeah, we're immediately in the fall state. Oh, and it's because we don't actually have anything. Once we're in the fall state, we don't have anything to put us back into the idle or the move state or anything like that. So what we're going to do is if We're going to check if the player hits the ground. So if player dot is on floor, return states dot idle. And we could also check if we want to put the player, like we could technically put the player in the move state from the fall state, or they can transition to the idle immediately and then go into the fall state. It could go either way. If we do it this way though, we have to make sure that there is player movement. So we'll say player movement happens here too. Okay, and everything should be working fine now. We go from the fall state to the jump state. Yeah, we're gonna need another variable here pretty soon. Let's just see if this works. There we go. And from the jump state, we also don't have any transitions. So let's go into the jump state, and we will say if gravity, or sorry, if player dot velocity dot y is greater than 0, then we're going to return the fall state. States dot fall. Oh my god. Okay, and by default we'll return null. And this is from the jump state. Eventually we're gonna have a slide state, but we haven't coded for that yet. So let's do that. And on the entrance of this is the first time we're gonna have a entrance function. So we'll say func enter state. Func enter state. And what we'll do in our enter state is we'll just say player dot velocity is equal to our player dot max, what do we call it? Max jump height? Max jump velocity, I believe. Or yeah. Okay. So player dot velocity is equal to our player max. And what I'll do here, technically we want to add this because we're in the fall state. Eventually we're going to have some coyote jumps, and in order to make the game somewhat fair, we want to just add this value. Okay, so run it again. Oh, player dot velocity is equal to dot y. There we go. Okay, and we want to make sure that we give the player movement in our jump state. We do have movement. Why is he like locked in place? Oh, it's in our fall state that we don't have movement. No, we do. What the hell? Player dot gravity, player dot movement. Let's see. Try this again. Okay, yeah. We seem to be stuck. Let's see what's going on. Player dot movement. Oh, I just realized something. Okay. In every single one of our player, let me look at our state here. Where's player movement? Okay, so we don't have player movement running in all of our states. We have it running in our move state. So let's make sure that we have it here. And we also want to make sure that when our velocity or when our move input is 0, eventually I actually want to add to this. Because right now we're giving ourselves a constant value of movement. But there we go. And we could also spam the jump button, which is should not be possible. but we'll fix that. Am I streaming on YouTube or on Twitch? I'm streaming on both. Should I upgrade to Unity 2021? I'm not sure. This is a Godot stream. All right, let's fix the jumps here, the infinite jumps. Basically, usually what I used to do was I would just have a variable called can jump, but I want to make this more consistent with like our states here. So what I'll do is in our false state is I'm going to say can jump. And this is what we did yesterday too, but I don't think I explained it as well as I could have. So what we're going to do is say var can jump. And by default, we're going to set it to true. And what we're going to do here is we're going to add a timer to this state. I'm going to call this coyote time. I'm going to call it coyote timer. And then we're going to have the onReady var coyote time. The Undertale OST is literally a roller coaster. Oh, you were asking Juho. I mean, you were asking YouTunes. Yeah, he streams on YouTube. The link is if you go onto self promo and you click, it's the latest post here. Oh, not this one. This one right here. All right. Let's get our coyote timer to work. I tried creating a timer with just like get tree, so maybe we'll fix this within time. I don't mind using like a timer node. I mean, if we did it via code, it would still be a timer node, but yeah, having it here in the actual state is not a bad idea. I do hope that it does save. So if I go into the false state, let me just make sure. Yeah, coyote timer is still here, which is good. So what we're gonna do is we're gonna create a signal, a timeout signal, and basically what we're gonna say in can jump, when we enter a state, we're gonna say can jump is equal to true. Or sorry, func enter state. In enter state, we're going to say can jump is equal to true. And then at the end of our coyote timer, we're going to say can jump is equal to false. And in our timer, usually I set our wait time to 0.2 seconds. We want to make sure that this is set to one shot, and we also want to make sure that we're starting our timer. So coyote timer dot start. And that's it. We could also include, if you want to make your game a little bit more dynamic, we can also make an an export value and call this our coyote duration. Coyote, call this coyote jump duration. And that's going to equal, we'll set it to default to 0.2 seconds, coyote jump duration. And what we'll do is we'll have a func ready. And in our ready timer, or yeah, in our ready function, actually, we'll just say start and we'll put our coyote jump duration right here. And that's it. And then you can always manipulate the coyote jump duration for whatever reason if you ever want to. Don't know why you would, but you can. And now what you could do is, you go into the fall and then you can just manipulate your jump duration right there. Okay. Oh, we have a ready function right here. Whoops. get rid of that. So on enter state, can jump is set to true. This is usually only if your previous, let me think about this. Yeah, we only want this to be set to true if we haven't already entered like a previous, like if our previous state wasn't the move state. Because you can go into the jump state and then back into the idle state, or sorry, the jump state and then back into the fall state, and then you could technically jump again, but we don't want that to be the case. So what we want to happen here is we're going to check what our previous state was. So we'll say if player dot previous state prev state was equal to states dot move. This is the only state that actually it could technically happen in, or I mean, it could technically be the idle state, but I don't know how realistic that is. What I think what we can do instead, because we do want to have coyote jumps for like wall slides and stuff like that, I'm thinking maybe the only state that we would have to be concerned with is the jump state. But you know what I'm going to do? I'm going to leave it on the move state and the idle state for now. And we'll update it going forward. Like if we see that we need some coyote jump from the slide state, then we'll fix it. But for now, we'll say if player.previous state is equal to states.move, or is equal to states.idle, then can jump is equal to true, and we'll start this timer. Else can jump is equal to false. And there we go. So then in the jump state, basically if player.jump input actuation is equal to true and can jump, then the player can enter the jump state. Otherwise, they'll go into the idle state. Or the only state that they can go into is the idle state. So let's run it again. See how it looks. There we go. Now I'm spamming it, and we also have coyote time. So if I run it again, and let's say we want to go here. Oh, maybe we can. Let me see. Yeah, we can. So you see, we're falling for like a split second, and it's not too powerful just yet, but it can make the difference in some of the gameplay. Okay. What is next? Let's see. Let's zoom in a bit more. What do you think is the basic definition of a video game? Oh, by the way, do you remember I'm making a 2D platformer? Someone also started the same thing a few weeks ago. He makes it from scratch in Python. Oh, that's pretty cool. Started making the same thing, like making the same type of platformer? Or like making tutorials? So, what's the basic definition of a video game? I don't know. Game played by electronically manipulating images produced by a computer program on a television screen or display screen. There you go. Okay. What is next? What is next? So in our jump state, all we can do is enter the false state. I think the next thing that we need to do is handle the slide state. So let's go into our states here. Let's make a new node. What I'm going to do is just go into move, duplicate this, call it slide. It's not really too important, but I just want the position to be correct, or like the file location to be correct. So we go into slide, rename this to slide, and I started doing, you know what I think I'm going to do? I'm going to keep it all capitalized. I think that's better. And remove the script, create it again. Automatically, it'll rename it to the name of the of the object, which is slide.ged. We're going to rename this to extend state.gd. Another thing that I noticed is that we don't fully capitalize fall.gd, idle.gd, and I think I should. So let's do that now. I wonder if it's going to mess with us here. Let me see. Remove this. And yeah, now it's saying load. Here, let's look at idle.gd. Can we rename this? Idle. If we save it. Yeah, it's the same exact thing. Okay, cool. Let me remove this. Load. Why is it? Okay, yeah, it does work, but I guess what happens as well is that we still have a duplicate of this. But if I search idle, it's not actually there. So let me rename fall as well to all fall. Move. Jump. I think Coyote Jump just makes gamers lazy because they don't have to concentrate and press precisely when Coyote Jump is enabled. I mean, yeah, but it's also like you want to give players the ability to like, or you want to make the player's life as easy as possible. Yeah, like, yeah, humans aren't perfect, obviously, right? So like they kind of have to be given some sort of like margin of error, or like, you know, allow them to feel like they're good at the game. And you have to make it subtle, yeah, for sure. Like I only make it 0.2 seconds. Like it's not enough to punish, or like it's not enough to have the player like manipulate the game. And what I also do is while they're in the fall state, they're still falling. So like gravity's still being applied to the player. So their jump is not nearly as high as it could have been if they just jumped. Actually, they still have an advantage if like a player who knows what coyote jumping is, they're definitely going to take advantage of it to get like further jumps, but it's not enough to make a difference in gameplay, really. Hello, Mr. Godot Man. Hello, Redstone Pro. Really just needed a little help. Well, guess that's what this stream kind of is. We're what I'm doing right now is converting this entire game into a tutorial. Basically, I'm just explaining what is happening live, and then we're gonna kind of trim it down into a YouTube video and see how it goes. So tomorrow morning, what I'm gonna do, I kind of have like this whole schedule set up where, yeah, I'm gonna stream right now. We'll finish the stream tomorrow morning. I'm gonna wake up. I'm gonna edit the video into, you know, a YouTube clip, upload that YouTube video clip, update the repository or create a brand new repository for the tutorial, and then we're going to start the next episode, which is going to be probably something similar to today. Will you make the source code? Yeah. The source code is going to be available. I update. Wait, so I'm not an NPC anymore. I'm a Godot person. I'm a player. Practical player. All right. What is next? Slide state. So let's get rid of all of this crap. Let's make, I'm going to reload the project because I don't like seeing multiple versions of the script here. Let's reload current project. So you're a practical playable character now. Yeah. We could say that. All right. So how is the slide state going to work? We're going to need to create a few variables. We're going to Oh, wait, also need to make a friction variable. So let's do that now. I think we'll have a slide. I couldn't figure out like the best approach for this. So like in our last project, or like in the one that we were working on yesterday, what we did was we included friction X and friction Y, and then we included a stopping friction, and basically, let's look at our slide state. Right now, what I've been doing is I've just been running player.velocity.y times equals friction, and friction is equal to 0.8. I mean, it works. We could leave it like that. It's not the worst thing in the world. Wait, we could just create a function called friction just so that people looking know what I'm doing. But yeah, for the most part, it's going to be just like a one-liner. Just found out about get collision point. Okay, dude, you need to slow down when you're typing though. And add child at that point, but it's not spawning at that point. What do I do? So you make sure, like, I'm not entirely sure, but get collision point. Make sure you're not confusing your local positions with your global positions. That's usually what I don't remember, but I remember like with raycasts. If you're talking about raycast, get collision point and all of that stuff. Sometimes it returns either the local position or the global position, and if you're setting it to spawn on the global or local position, it could mess everything up. So yeah, you just got to figure out which one you're dealing with. To debug, just make sure you're printing out, what these global positions are and where do you see it relative to the object you're spawning it from. All right. In our slide state, let's make the func update. Let's make the func friction. Let's make the func enter. We don't really need to worry about enter state. So what we're gonna do here is, and we have to add the position is right. Its position is equal to the right spot, but it's still going way off. So if it's going way off, then that means that it's not right. If you want, send the code on the Discord server, and I can look at it after the stream. Because it's kind of hard to communicate via text and me talking and all that. We will be dealing with some collisions during this tutorial, but not really today. Like, I'm going to be working with Raycast right now, actually, for us to handle the slide state. So, we'll see. Maybe I can answer it on stream if we, hit that part of it. Or if somehow it, relates. So what I'm going to do is create another node, and we'll call this node Raycast. Oh my god. Raycast. And we're gonna call this right. We'll call this right top. We'll duplicate this. Call this right bottom. And we're gonna have to set this to 0. Set this to 12. We'll set both of these to 12. Actually, I'm gonna have to mess with the positioning here. So right top, let's throw this up here. Now I'll put it on, actually, yeah, we're gonna put it right above the player. If we move it, there we go. And this one, what's going on? There we go. All right, let's duplicate these. But this is going to be called left top. And this will be called left bottom. And we'll set these both to -12. There we go. And actually, I think these are way too big. So let's set this to, for now, we'll set it to 8. We're probably going to have to mess with these values later on once we replace the sprite here. -8. Okay. So what we'll do here is in our player script, let's also create a reference to this. So we're going to have to create one for all of them. We'll say onReady var onReady var right top and we'll call this right top raycast. And here, let me just duplicate all of these. Left top and left bottom raycast. Okay. Okay. So we're gonna have to create a new function, and this is going to be checking for walls. So func check. We'll say func next to wall. And we'll say get next to wall, or get next to wall. I think that's a good name. And what we'll do in get next to wall is we'll check if the right raycast or the top raycasts are colliding with anything. So we'll say if, well actually what we're gonna wanna do is, yeah, we're gonna create an if statement for each of these, but if one of them hits, then we won't be concerned with it anymore. So we'll say if, let's say, well actually first let's return, let's update everything. So we'll say right top raycast dot force raycast update, and then we're gonna check if it collides with anything. So if right, and can you guys see it here? Let's, if right raycast right, oh this is right, let's make sure we're consistent here. Right top, if right top raycast dot is colliding, return vector 2 dot right. So we can return vector 2 dot right, and I think what we'll also want to do, either we could do this here or we can do this in in like one of our states when we are running get next to wall. Let's just do this for now, but eventually we might want to create another var called last wall on or something like that. But we'll see how it goes. All right, so yeah, we'll do the same thing for the bottom raycast. We'll say, oops, bottom raycast, bottom. Okay. And then we're gonna want to do the same exact thing, but for the left side. So let's copy all of this again. But instead of right, we'll say left. And this is the bottom raycast. Just make sure this is set to left. And copy this one last time. And do the left top expected to what? Oh. Oh wait, what? Oh yeah. There we go. All right. I hope this isn't confusing. If you guys have any questions about like what is going on, just let me know. I got a deer baby, nice. Venison? I've never had venison. Alright, so we got our right side, right top raycast, force raycast update, and we're returning vector2.right, vector2.right, vector2.left, vector2.left. So now what we want to do is when we're in the fall or jump state, we're going to check if get next to wall returns vector2.right or vector2.left. Another thing that we want to do is that if none of these return anything, we want to make sure that we're returning null. That way, if null happens, we don't do anything. So let's go back into here, and what we'll say is if player dot get next to wall does not equal null. Oh, make sure this is a function. We'll say return states dot slide, and let's do the same thing for the jump state. Do I know how to make it local? Positioning wise, it really depends. Like if you have, you would literally just say position instead of global position. Is it possible to apply a normal map in a tilemap 2D? I believe it is. I don't remember how to do it, but I'm pretty sure it is. I remember trying to do it. I guess don't quote me on that because I can't show you how. But I remember seeing like, let's see, rendering. I don't want to spend too much time on it because I don't think I remember how. Saltoons posted an update video. Yeah, I actually haven't seen Saltoons until he rated me. I didn't know he was a streamer or a YouTuber. But yeah, he's very good. I do like Saltoons. Okay. Thank you for the follow, Redstone Pro. Yeah, dude, I'm not entirely sure if you want to post like your code on the Discord, and I'll look. Like I said, I'll look at it on after the stream. All right, let's finish this up. In the slide state, we're checking if we go into the slide state, which we do. And what I think we want to do as well is when we enter one of these states, we reset what our previous slide was. So what we could do is we could technically create a variable here. Call it like last wall on or something like that. But we could also do this on the entrance of the slide state, which I think would make more sense because it would just give us more information because we don't know if we're going to be in the fall or jump state. So yeah, if get next to wall does not equal null, then we'll enter the slide state. And then in the slide state, when we enter the slide state is where we'll pick last wall on, or just on whatever wall. So we'll say var wall on, or we could say last wall on or wall on. It doesn't really matter. I think we're gonna say last wall on is equal to vector2.0. And actually, last wall on it doesn't really describe what it actually is, because it's actually it's going to be a vector2. So we could say last wall direction, but I've used last wall on for so long that it just makes sense to me. So we'll leave it like that. Vector2.0. And what we'll do in our func enter state is if, or we'll just say last wall on is equal to vector, or sorry, is equal to player dot get next to wall. And what I'm thinking we'll do, instead of returning null, is we'll actually return vector2.0. I think that makes more sense, or gives us more freedom in case of something. So we'll say vector2.0. Okay, so in enter state, last wall on is equal to player dot get next to wall. And then in our update function, what we're going to do is say if player. So there's going to be a bunch of if statements that we have to check for. One of them being if we jump up, or if we're leaving the slide state from sliding all the way down, or if we're leaving the slide state from going all the way up. That it's technically never going to be an issue while we're in the slide state because we only fall down, but in the climb state is when it's going to be even more difficult, or just more of a nuisance. So while we're making the slide state, let's also make the climb state. Actually, I don't want to get distracted. Let's finish the slide state. Let's do if if player dot jump input actuation is equal to true, then we're going to return states dot jump. If get next, or if player dot get next to wall. Is equal to vector2.0. What's up, Yesfa? Here's a link to the normal map to the tile map. So, YouTunes, I don't see it, unfortunately. I think maybe there's a setting on YouTube that doesn't allow people to post links. So if you want to post it on Discord, and I'll copy and paste it onto the stream. All right. Take out the tea bag. I want maximum caffeine. I leave the tea bag throughout the entire drinking process. All right. So enter state. Why is this expected? Oh. We'll return states.fall. Are there any other states that we need to be worried about? Technically, if is on ground, we're also going to check for that. So we can't have the player in the slide state if they hit the ground. We'll just go into the idle state. So if player dot is on floor, return states dot and let's make sure we capitalize this. Sent it on this Discord. Okay. for anyone interested. I hope you guys see the link now, since it's technically my link. All right. Slide. Okay. Return states.jump. Return states.fall. That should be it. We go from the fall to if not next to wall, and if we're in the jump state, if not next to wall. Oh, also we want to make sure if this is not equal to vector 2.0 now, since we renamed that. There we go. Okay, moment of truth. Does this work? I hope so. Oh, no. Let's see. If player.get does not equal vector 2.0, return states.slide. We're consistently always checking if next to wall. Wait, let me see something. Do we ever enter the state? So let's go into our player function really quick, and in change state, we're going to run current state. Print. No, we'll just say input state, or doesn't matter too much. And let me get rid of whatever we're spamming here, whatever this velocity is. Where is it? In the physics process. Okay. Okay, so our raycasts aren't working just yet. Let's see why. Exclude parent. Collision mask is set to whatever it is. Collide with areas, and right now we're only colliding with bodies, which is correct. What is going on? Let's see. Get next to wall. Are we running the right function? Get next to wall, get next to wall. In our fall state, get next to wall. In our jump state, get next to wall. All right, so let's see here. So we are running get next to wall, and if left top raycast is colliding. Oh, we do need to make sure that we're not colliding with ourselves, and by default it does say exclude parent. But what I think is technically, here, let's just print this out. So yeah, it's not printing that we're colliding with any walls here. Let me see our layers, our collision layers. Our collision layer seems to be set to 1, so it should work. See. Yeah, layer 1, our collision layer is set to 1. And we are colliding with it on our player node, so yeah. What is causing this? I wonder if our raycast is not big enough? Yeah, let's set these to -13. I don't think that's the issue. And we had it working yesterday, so it's probably some silly error we haven't noticed yet. Let me make sure it's not colliding with the player. Oops. What the hell? Okay. In update for jump, if return get next to wall does not equal vector 2.0, we return states dot slide. Let's see here. Yeah, collision mask is the same. Let's see what next to wall was printing. In raycast node, if raycast.targetPosition.x forced raycast update. Ugh. Forced raycast update. We could write it this way though. I think this is a better way to write it. It's simpler. And we just check what the target position here is. So I'm gonna copy this. But still doesn't solve, or like doesn't. Let's see, right top, left bottom. Force raycast update here. Let's rewrite this to get next to wall. And let's make sure raycast node is actually equal to something. So we'll say at onReady var get raycast node, or sorry, raycast node is equal to raycast node. Last wall, let's get rid of this. And see if that fixed it. Yeah, it still doesn't solve our issue. I don't know why. I'm assuming maybe it has to do with our tilemap here. Because nothing else seems to be the problem. See, collision mask is set to 1, exclude parent. Here, wait. I'm gonna move all of these out of the way. I'm gonna move this collision mask to below the player. We had it working at some point. It is printing the correct value. It's just we're not switching to the state correctly. Okay. All right. At least we know. I was convinced it wasn't because it wasn't printed. Oh, because we removed the print statements. So I assume maybe just our last function was just written incorrectly. So for raycast, we return it null here. We'll return null. I don't mind returning null. So what we'll say here is equal to null. Do that. And in our jump state, if it's not equal to null, do that. And in our fall state, if it's not equal to null, do that. And in our slide state, nothing really happens just yet. Let's make sure we're adding gravity. What is it? Player.gravity? Player.gravity delta and player movement. Okay. Moment of truth. I mean, the slide state doesn't do anything just here. Oh, we still don't enter the slide state. Let's figure that out. If it's not equal to null, we return. Wait, let's look at the fall state. Let's also make sure we're returning null here. Maybe that's why it wasn't working. Let's also make sure we put this back in place. The game jam me and Ju are joining starts tomorrow. Nice. Here, so, dude, am I dumb? What's going on? We got rid of that print statement. Let's print it again. What place did your game in, Chev? I don't know. I'll check it out. Yeah, okay. Next to wall is -1. Push-ups until failure. All right, give me 1 second. Let me just solve this because dude, I'm like getting a little frustrated. It also says -1 here when we're in the idle state, which is odd. Okay. Next to wall is -1. It's definitely returning -1. And just to make sure, what I'm going to do in our player, or over here, let's just do next to right, print next to left. Okay. In our fall state, next to left. Next to left is printing true, which is great. Oh, but it actually, I think it's printing because we have it in our physics process. Here, let's get rid of that. Run it again. And I can't tell at the moment. Let me clear. How do we clear our output here? Oh, there we go. So, okay, yeah, something is bugged here. Dot is colliding. It's colliding with itself. That's the problem. All right, I'll do the push-ups now. Whew. Oh. Is my camera still working? I'm struggling. I did go to the gym today. All right, I'm gonna leave it at that. If you take 100 push-ups, I'll give you some KFC. No, there's no way I can do 100. I think the max I've ever done was like, I'm pretty sure the max I've done was like 72. But that was when I was in my prime. Alright. Let's try to figure out what's going on here. $40 is pretty good. Alright. You gonna do some right now? Alright, sounds good. Let me know. Dude, why is... Oh, okay. So one issue that we have is that we're colliding with ourselves. So what we're gonna do is we're gonna set our collision mask to 2, and then remove 1. And then on our tile map, I'm gonna set our collision layer to 2 and 1. So that'll help us a bit. I don't know if that's the problem. But we are printing next to left wall. Let me make sure. Okay, yeah. So now next to wall, next to left is true, so returning left or right. Let's see here. So if it's not equal to null, return states.slide. Why are we not going into states.slide though? Here, let's do this. In our oh! This shouldn't matter, but for now, we're gonna just comment everything out. Pretend like movement doesn't exist. If we get into the slide state, it's just gonna keep us there. Dude. It's saying next to left wall too. Node not found slide. Dude, oh my god. I feel so dumb. We created the slide node, but we never actually added it to our player. Oof. I should make this its own scene and update it from there. Oh my god. Alright. There we go. So, I mean, it shouldn't happen like this, but we got it to work. That took way too long to figure out. Damn, it's been a while. How much did you get? Okay, so yeah, now we can get into the slide state, and what we're gonna do in the player function, well, yeah, we'll run friction right here, and what we'll say here is player dot velocity dot y times equals var friction. Let's create an export value here. So at export friction value, say slide. Let's call it slide friction. Equal to, by default, we'll set it to 0.8, or actually 0.7, no, 0.8 is good, times equals slide friction. And that's it. Oop, make sure you set this to var, and run it. There we go. Now we just gotta make sure that we go from the slide to the fall state if we're not colliding with the wall anymore. And it seems like our... Here, let's see. Yeah, it's just that our hitbox is way too big right now. Let's go back into our player. For now, we're going to want to make this a little bit more precise later on. But for now... For the bottom right and the bottom top, we're going to set this to the max size of our tile here. So that's, what is that? Where's our ruler? 4 pixels. We might do 5 pixels. Yeah. So set this to 5. Set these both to 5. And we'll set these both to -5. And the reason why you want to use raycasts over, let's say, just checking for next to wall is because you want there to be some like margin of detecting if you're next to a wall. And you also want some sort of margin, like eventually what we're going to do is actually set this to like, instead of negative, relative to this box, instead of making it 1 pixel bigger, we'll make it 2 pixels bigger. And if the player presses the grab button or the climb button, they'll grab the wall if they're 2 pixels away, and they'll only enter the slide state if they're 1 pixel away. 1 pixel away. Do you have a thing that where the gravity gets stronger when you fall? So yeah, I mean, gravity doesn't get stronger. Your falling velocity gets stronger, and that's just what gravity is. But what we can do, and what I plan on doing eventually, is if there's down input from the player, we'll make them fall faster. But yeah, gravity already technically makes the player fall at a quote-unquote significant rate. Or, you know, it does get stronger. What just happened? Did we crash? Okay. Yeah, so like gravity's always being applied, and you can see, might be hard to tell, but as you fall, we are falling faster and faster. There's no limit just yet. But we will be setting a limit. Usually I set the limit to 300 pixels. So the velocity is 300. But yeah, we'll have to figure out what we want those values to be. Okay. What is next? Wouldn't that change based on display if it's based on pixels? No. There's like, it's based on pixels in the engine rather than pixels on the display. Okay, so in our slide state, we're gonna handle our jump state now. So what we're gonna do, we're gonna go back into our jump state, and we're gonna check if our previous state was the slide state. So what we'll do in our enter state is, and like I said, we already wrote this yesterday. We're just making it cleaner now. We're gonna say if previous state, if player.previous state dot prev state is equal to states dot slide. We're gonna want to grab what our previous wall on was, and I think we did that already. It's important, and actually we're gonna want to check if it's the slide state or the climb state, but we didn't do the climb state yet. So what we'll do, last wall on our exit state. Actually, we have this on enter state. That's all we need. But what we want to do is make sure that we are resetting this value. Actually, it doesn't matter what this value was. Yeah, let's leave it. So in our jump state, if previous state is equal to states.slide, then we're going to say states.slide dot last wall on. We're gonna do something with this value. We're going to say player dot velocity dot x is equal to our last wall on times -1, or we'll say -1, and we're actually gonna say plus equals -1 times this value here there's one problem with this, and that problem is that if our previous state was states.slide, technically if we enter the jump state, we'll just go straight into the slide state again. So I think what I did originally was that in our jump state we actually can't go into the slide state. That's one solution. I wonder if that's what I did last time. Let me see. If we look at our jump state, Yeah, we never actually go into the slide state. We could have it so that you could go into the slide state, but I don't think we're going to do that. Instead, you would go into the climb state. But we still need to handle several different types of jumps. One is if you are going from the slide state into the... we'll figure it out as we go. Because you can go from the slide state to the jump state, or from the jump state to a next to wall, and if we're next to a wall, then we can do a jump, like a wall jump without ever entering the slide state. So there are a bunch of like different case scenarios, but we're first just going to handle the slide state, the transition from the slide state to the jump state. So player.velocity dot x plus equals -1, and I also want to see how we handle this, because either we can add velocity to the player immediately, or we could do a jump movement function. And basically what that would be is we would set our player's velocity to equal our last wall on, let me see, and just keep it there until we're done. That's one way to go about it. Another thing that we could do is just force input from the player to make them go to the right for like a certain amount of time. There are so many ways to go about it. We'll try it this way first, and if it doesn't look good, we'll go about making a jump movement. Or actually, no, we have to do jump movement now. So let's do func func jump movement, and we're gonna include. No, we don't have to include delta. Say that. And we're gonna create another variable called jump lock, var wall jump lock. Wall jump lock is equal to false. And in our exit state, let's throw it down here. Lock is equal to false, and if our previous state was equal to states.slide, wall jump lock is equal to true. And let's get rid of this. We'll leave player velocity to this. We're also going to say, and we're going to create another variable called manipulated jump. Is equal to false. And in our exit state, we're going to set this to false as well. What is the song that's playing? Oh my god, that was ridiculous, but I liked it. A Terrible Fate. Oops. Alright, player jump lock is equal to true, so then in our jump movement, wall it's so ridiculous. If wall jump lock, we're gonna say player dot velocity. Welcome to the Hazoo band, yeah. Kazoo. Player dot velocity is going to equal our last jump, our negative last wall jump, or no, we could just say last wall on, which we haven't saved yet. So let's actually make sure that we have. So we'll say var last wall on is equal to vector 2.0 And over here, we'll say last wall on is equal to states dot slide dot last wall on. We could technically, I think we could have our player access this variable, but I kind of like the idea of having all of our own variables in each of our states. Makes everything kind of consistent here. But we do need to make sure that we set this back to vector 2.0. Actually, yeah, we'll leave it as vector 2.0. I'm not sure if we need to. But let's look at the slide state really quick. I want to make sure, yeah. Player, last wall on, okay. So, player dot velocity is going to equal last wall on times our player dot min jump velocity. And this is going to be dot x. So player velocity dot x is equal to last wall on. Technically, this is going to be dot x, and player min velocity is just a raw value. And our min jump velocity is negative, so it's gonna make us jump to the opposite direction of whatever this is. Sounds like a wacky, funny game of the medieval times. Yeah. I'd like to see what that game, what it's from. I mean, it's called Outer Wilds. Okay. And we also want to run jump movement here. And another thing we want to do is we want to say, if we manipulated our jump, we want to make sure that we can't run player movement while manipulated jump is running. So, or yeah, while our jump is running. So, what I'll do here is say, if manipulate, or if not manipulated jump, manipulated, if we can spell manipulated jump, then we'll run player movement. And let's make sure we actually set this to true here. Manipulated jump is equal to true. And there we go. So, there's one issue here, and I'll show you what that issue is. The velocity of the player, while they're in the jump state versus while they're in the fall state seems to have like some inconsistency, and that's because we're just setting it to a random value, which I shouldn't do. What I should do is set it to whatever our move input is. So let's actually go back into the jump, and instead of setting it to this, what we're going to do is set it to player dot speed. And I think that will be much better. Let's see. What's going on? Times speed. Oh, times negative speed. So we'll say negative last wall on, or let's just say -1 times last wall on, so I can see it visually. How goes it today? Pretty good, I have to say. We're just working on a new. I think were you here when I was rewriting some of the code? I think you were. So yeah, it does look a little strange. Because there's no animations yet. It's good. I was around-ish, yeah. So, what I plan on doing now is I'm actually going to turn this into like an open source project. So I'm just rewriting everything that I did yesterday. I'm rewriting, and I'm gonna convert this into a YouTube video. Like I'm recording right now, and I'm just gonna clip out all of the parts where I'm like talking to you guys, and hopefully make a decent YouTube video. We'll see how it goes. This is my first time ever actually trying to make a tutorial. Okay. What is next? I think we could start working on the climb state. Let's see. Let's add that right now. Can we add the... No, we didn't. Okay. I'm going to duplicate... We'll duplicate slide. Make it climb. Go to climb. Rename this to climb. Move the script. Create a climb script. Extends state.gd. And let's throw this into our states. And we're gonna copy everything from the slide state because it's kind of similar, but not really. We're not gonna have any friction. We're not gonna have any player movement. We're not gonna have any gravity. No friction. Last wall on, we will keep. Jump input actuation will still put us into the jump state. Not next to wall will still put us into the false. Actually, this depends. We're gonna have to create a few variables, a few if statements for this. And if is on floor, this could go either way. I think what we'll do is actually remove this as well. So you can only go into the jump or fall state from the climb state. And it looks like the coding would work with without any issues. Game dev. Yeah, it's kind of scary. How like it could do everything. But I will say that it's still pretty difficult to like I feel like creating stuff like this is still pretty hard for ChatGPT, but maybe I'm wrong. I don't know. I remember exploring it with GDScript and it wasn't as impressive, but I've only tried it with GPT-3. Alright, let's see, slide friction we can get rid of, last wall we will keep. On exit state, yeah, it doesn't really matter, we'll leave this variable here. Let's do func climb movement. If I can spell. And what we'll do with our climb movement is, we'll say if player.move up input is, oh, sorry, we don't have move up input. We have if player.move, I forgot what we called it. Movement input. If player.movement input is equal to vector2.up, or we can say .movement input.y is equal to -1. We're going to want to move the player up, so we'll say player.velocity .y minus equals, we'll say speed for now, but actually what I think we should do instead is actually create an export here. We'll call it climbing speed. And we'll say our climbing speed for now is 25. Nothing that would make it break. Yeah. Player minus equals. Okay. Then we have to do the same exact thing, but for vector2 dot down, which is just y equals 1, and plus equals climbing speed. And that should be it. And we'll just put climb movement. Okay. If jump input actuation is equal to true, we'll set the jump state. If not next to wall, we'll go into the fall state. And we'll also do some stuff with this pretty soon, but for now, let's see if this works. Let's also, I forgot what our climb button was. I think it was C. We shall see. Oh, and we need to make sure that we're going from the slide state to the climb state. That's the only state I think we're gonna have it work with. Let's see. If player dot climb input is equal to true, or just climb input, whoa. Okay. Obviously, we don't want this to happen, but it's kind of cool. Okay, what we'll do here is, well, obviously our climb speed is too high, but I think what we'll do is also add a climb friction. Yeah, because right now, yeah, let's do this. It's just equal to negative climb speed and positive climb speed. Let's see how that looks. I'll see you later. Peace, you tunes. Okay. And also going to say elif here. We're also going to say else. And just set our velocity to 0. Otherwise. And there you go. Oh. Alright, so we want to fix this too. So this is an issue. We're going from the climb state, and the second our raycast disappears, we go back into the fall, but then from the fall state, we just go back into the climb if we're still holding the climb button. And so what we want to do here is when the player goes into the fall state, immediately we want to push them to the left a little bit, or even like maybe auto make them like move over. So like right now what I'm doing is I'm holding up and left so that the player like climbs over. But I think what we want to do is make sure that this automates. It's a very subtle thing, but it does make the game feel responsive, or like it just feels polished when you do this. So we're gonna make that happen. Make it happen automatically, I mean. So what you want to do is in our slide state, when we go into our climb state, and this is what we were working on yesterday. I think this is kind of where we left off. When we enter, let's see. If our velocity dot y is greater than 0, we return our fall state, which is what we go into. And from the fall state, let's see. How do we do this? Oh wait, no, this is from the climb state. Okay, climb up direction is equal to vector to, or equal to player next to wall, and then we return the jump state. And then from the jump state, if we enter from the climb state, if our state climb up direction does not equal vector 2.0, then we do whatever this is. And basically, we've manipulated our jump. We set climb jump lock to true. Let's get rid of this. Player.velocity.y is equal to player.min jump velocity. Yeah, let's do all of this here. Okay. I'm gonna, for the most part, I'm probably not going to look at our previous code just to make sure maybe like it's the right approach. If we don't get it on the first run, I'll look back at it. But it's not like complicated or anything like that. So give me 1 second. I do want to have similar names though. Climb up direction. Okay. Okay, in our enter state, we're gonna reset this value. So climb up direction is equal to vector 2.0. And if we go into the jump state, or let's say, this is equal to null and jump. Wait, and our velocity dot y is less than 0. Player velocity. Then we're gonna say climb up direction is going to equal our last wall on. There is potential for a bug, and yeah, a bug could technically happen if we have like a certain scenario where the player is climbing next to two walls that are like right next to each other, but I don't think I'm ever going to design a room like that. And if you design a room like that, yeah, then that's going to be a potential bug, and you would just have to consider that to be a problem. What I mean by that is if the last wall on changes at any point while you're still in the climb state, it's going to give you some problems. Yeah, just don't do that. Climb up direction is equal to last wall on, return states.fall, and also return null. I think by default it returns null, but I think it's good to also write it there. Okay, climb up direction is equal to last wall on. So if we go into the, this is from the fall state. This, what we should do instead, is we're gonna have another if statement here. What we're gonna do is, if this is false, if this is true, then we'll return states.jump. States.jump. Here, let's do this actually. If our player.velocity.y is less than 0, return states.jump, and we'll throw this in here. Else. Like that. And we'll return null otherwise. What is... Okay, so let's go back into our jump state, and now we have to handle our enter state from the slide state. So if our previous state was the climb state, elif player dot previous state is equal to states dot climb. What should I talk about at this stream? You asking me what you should talk about? Okay, so manipulated jump is set to true. It's equal to true. Wall jump block. Technically there is a wall jump block, but it's a different wall jump block. I think what we'll do is check what our previous state was. Depending on what our previous state was, we'll manipulate this value. Since you know what you want to hear. There's nothing in particular I want to hear. Unless you want to, you know, just tell me, you know, feed my ego. Tell me how great of a game dev I am. You know? I'm kidding. Don't do that. So wait. Manipulated jump is true. Wall jump block. Technically, there is a wall. But this, you know, I think I should call this. I should call this slide jump block instead, because it's like there's a difference between slide jumps and climb jumps. So let's do that. Call this slide jump block, and we're gonna make another variable called climb jump block. It's equal to false. Let's make sure we save these. Slide. Is like seeing tons and tons of gold sinning brigid in my eyes. I'm so glad. Slide jump block and climb jump block is equal to false. Okay, so if our previous state was states.climb, it really depends if our climb up. So we'll say end states. Oh my god. End states dot climb dot last wall on does not equal vector 2. Wait, actually, do we save these? We don't actually reset this value. What we do need to do is, oh wait, yeah, we do update this value. So climb up direction is not equal to vector 2.0. If, wait, where is it? Jump. Climb. Oh my god, climb up direction does not equal vector 2.0. Hey yo, how's it going, Half Moon? I think it's time for Undertale again. Okay. So if player the previous state is equal to states.climb, and I mean technically we could get rid of this, but if previous state is equal to states.climb and states.climb climb up direction does not equal vector 2.0, then manipulated jump is equal to true. Climb jump block is also equal to true. climb jump block is equal to true, and last wall on, I guess we should probably also save. So last wall on is equal to states dot climb dot last wall on. I think that's what we have saved here. No, we don't. Oh yeah, we do. Last wall on is equal to vector 2. Okay, perfect. This is kind of like Undertale. Alright, sure. Let's listen to it. Retro gaming vibes. Are these gaming songs? DJVI. Magnus Paulsen. The Fat Rat. I know the Fat Rat. But yeah, is it songs that I could use on stream? Alright, I'm trusting you. Oh wait, whoops. Okay. If manipulated jump, okay, on exit state we set manipulated jump to false, so we're also going to say a manipulated jump is, or if manipulated jump, if not manipulated jump, run this. And actually, we don't really need to concern ourselves while we're in the slide state. We're still gonna run this this line here, so I'm gonna get rid of it for now on the slide state. Okay. Manipulated jump is equal to false. Climb jump block false false. Alright. What is next? In our jump movement, we're going to say elif jump block, climb jump block, player dot velocity on the y-axis is going to equal our min jump velocity. It might actually be less than this, but we'll say min jump, or yeah, we'll set it to our min jump velocity, player dot min jump velocity. And on the x-axis, we want it to set to whatever our last wall on is minus or times -1. So this is going to be -1 times player dot, or not player, but you know, we might actually want to use player rather than the states to record these values, but I'm not sure yet. I'm going to do some research on that really quick, or off stream, I mean. So we'll say we can actually record this climb up direction, or we could also just write last wall on, and this should work. I hope. Player dot velocity dot x is equal to last wall on dot x times equals last wall on times x times player dot min jump velocity. I'm gonna say divided by 2, but it might be a different value pretty soon. Let's see, -1 times last wall on times min jump velocity. Oh, also this is already negative, so we can get rid of this negative value here. What's going on? Player is not declared. What? Oh. Okay. Dude, that was so much work. Let's see if it... We crashed. Okay, perfect. Index velocity on base character 2D. Invalid index velocity. What? Player dot velocity dot y. jump movement. If not manipulated jump movement. Invalid index of, oh, we wrote velocity. Okay, velocity, okay. It crashed, so it means it works, yeah. Don't you guys know? That's the game dev way. No, I like when it crashes, because then it's like, oh, here, wait, this should be plus equals. And the value is wrong, on the x-axis. This should be, I guess we could set it to negative. I guess last wall on is on the left. And this is negative. Okay, yeah, so it is, yeah. Okay, wow, that was too fast, and we're also not exiting the state anymore. And that's because we set our velocity here. We want to make sure that we're resetting our velocity as well, and we're also not running gravity. We're not running gravity on the jump state? No, player.gravity. Okay. Huh. What's going on? I mean, we probably need to reset the player's gravity. Yeah, that's actually something that's important. So on the enter state, we're also going to want to say player. Actually, I'm trying to think. It would be important here, definitely. But on the enter state, I actually don't want to remove, I don't want to reset gravity. So let's try this again. Let's see what our gravity is, or velocity is. In our physics process, I'm just gonna print it out here. Or you know what? I'm gonna make a second label because I think labels are great for you guys to see what's also going on. Instead of me printing it out in the output. So let's put it right here. Make another label. Call this motion label. And it's also nice so that it doesn't spam our output for, like, you know, when I want to print more important things. Make sure this gets set correctly. Okay. We'll say motion label dot text is equal to str of velocity, and that's it. Let's throw this up here. Okay, we're in the climb state, and yeah, we're just adding more and more velocity. I didn't realize this, but okay. Did I do? Maybe this is what we left off on yesterday, because to do this, to just set our velocity to some random value, we don't have anything that lets us exit this state. Because you only enter the false state once velocity is equal to 0 or is equal to a positive value. So either we add a timer to this, or oh wait, this is the wrong function. Whoops. In our jump state, we do jump movement. Oh, okay. This is probably a better solution. What we do is we set our player velocity on the x-axis to keep going, but our initial velocity on the y-axis is going to be put on the enter state. So let's get rid of this. And on enter state, we'll say player velocity.y is equal to our player min velocity. And that should be the solution to all of our problems. There. Wait, what the hell? I think maybe we set the value too high. Yeah, that's a little crazy. Yeah, what the hell? Why is it so? Why is it like speed? On this is equal to player. Oh, that min. Here, let's try this. And I think look at player movement really quick. Yeah, right now we're just setting it to our speed. I'm gonna figure out a better way to handle movement by tomorrow's stream. For now, in our climb state, or sorry, in our jump state, I'm gonna set this equal to speed, or equals negative this value, because we want to have some sort of like acceleration going on in the game. But right now our player is just like consistently moving to one speed. So yeah, if we look here, oh, this is also way too much. Let me see. It should not be negative. And let's see. Our min jump velocity, we're gonna divide this by 2. Run it again. See how that looks. There we go. It's a lot better. I might even want to make this slightly slower, or yeah, increase our. Like I want to push him closer to the left, but it really depends on what our new sprite. What our new sprite is gonna look like. So I won't mess with it too much because these values have to change. Yo, how's it going, Sass? How you doing, man? But yeah, it works on the left and it works on the right. Let's see. Our jumps are fine. We can go from the climb state. One thing we haven't worked on yet. Wait, actually. Yeah, our jumps are consistent. But it's only consistent because we set it to like 50 and negative 50. We want to have some sort of acceleration going on. Is this going to be a new game? So this is going to be, hopefully, I can try to tell you what like my whole game plan is with game dev in general. What I'm doing right now is I'm remaking how I made like Memory, but in a much more organized fashion, and also in Godot 4, not in Godot 3.5. While I wait for the demo to come out on, well, it's already out on Steam, but I'm waiting for the Steam Next Fest to showcase it, and if people like it, I'll keep working on it. In the meantime, I'm gonna work on just showcasing how it's all done in Godot 4. Yeah, so all of this is going to be on a YouTube video with the repo, you know, out for everyone to download. Really like the demo so far. Oh, I'm glad you liked it. But yeah, I'm doing the. I also plan on doing the Kickstarter within the next few months for the game, probably during the Next Fest. So if people like the demo, then they could participate in the Kickstarter if they want to. And if that does really well, then we'll keep on working on it with. Hopefully, by the time that demo is done, we'll have this version and it's kind of open sourced. So I don't know what I'm gonna do, like how to balance all of that, but I'm kind of excited for it. We'll see how it goes. But yeah, let's see. I might just end the stream here, because there are some like slight things that I would like to add, but I'd have to do some research. What are some other states that we need to? Let me see what we did in yesterday's version. Oh, we still have to do the dash. Yeah, I'll do the dash today. I think that's the final movement, or like one of the most important movements. Basically, we have slide, climb, jump, fall, move, idle, and dash. Those are like, yeah, 1, 2, 3, 4, 5, 6. Yeah, the 7 states. Seven states of memory. Then add them on stream. But the player controller you're making now is not going to replace the one in memory. It might potentially. Like, it really depends on how much time it takes. Like, it really depends on how the Kickstarter goes. If the Kickstarter goes really well, I would like to make the game as like perfect as possible, and that means redoing the entire like movement, which is what I'm doing right now. But that's gonna happen in 3 months, or in June. So June 16th is the start of the next fest, and that's when the Kickstarter is going to run. So like, yeah, if that goes well, then this version should be almost done by then, and yeah, and it'll be like 10 times better, I hope. Or just much more polished. There wouldn't be any bugs that I would see in the game. Alright, let's finish up the dash state. And then tomorrow I think we'll do tile maps and animations. Okay, let's just grab one of these states. We'll duplicate climb state. Name it dash. What's most similar to the dash state? Probably the move state. Okay. And let's throw this into our states. And in our states, let's just make sure we have dash in there. Yeah, we do. Alright. Cool. Alright. In the dash state, there's not much that goes on. We're going to have an enter state for sure. We're also going to have a func exit state. And in our physics process, what I think we'll do is we're just going to set our player velocity to some value. And it'll just be consistently that value until you exit that state. So player dot velocity is equal to player dot movement input dot x, or no, just dot movement input. Oops. Dot velocity. And we want to multiply this by our dash speed, which we don't have yet. We'll make that right now. So we'll say export dash speed is equal to What do we usually use? I want to say 240, but that might be wrong. Let's see. 240. Okay, yeah. Var dash speed is equal to 240. What's going on? There we go. And on our exit state, we're gonna set. This would be a good opportunity to check if manipulating our dash speed is a good idea. So I will leave it here. I won't do anything just yet in the exit state, but don't know if it's gonna work well. And for our update, all we're gonna do is check for if our dash duration has ended. So let's do that. Let's go into dash. Actually, another thing I might want to do with our dash state is instead of checking for durations, we can also check for just the distance that we've traveled. Or there's so many ways to go about it. I think for now, yeah, I think how I have it done in the original memory is that we just have a timer that runs for like 0.3 seconds or 0.2 seconds, and then after those 0.2 seconds we exit the state. The only issue with that is that we can't I wasn't able to pinpoint a certain value. Like I kept having to like test the value or like test the timer to see what the distance was. But it's probably a good idea to just calculate that value with some maths, but I'm not good at math, so for now we'll just use a timer. But eventually we might update this. So what I do is I set our timer to 0.2, and what we could do here is actually add this to an export val. So we'll say export var dot dash duration. Duration is equal to 0.2. And in our update, well, actually, let's make a signal here. So go into node, timeout, connect the signal, and what we'll say, we'll actually make one more variable called dashing is equal to true, or no, equal to false. And on the enter state, dashing is equal to true. And on the timer timeout, dashing is equal to false. Dashing is equal to false. And in our update function, if not dashing, then we're going to return, we can return fall.
Don't worry, buddy, you're doing fine.
Thank you, Octo. States.fall. Oh my god. And we'll also return null. So usually, if you're in the idle state, if you're not dashing, you're immediately going to go into the fall state. From the fall state, you'll just enter the idle state or whatever you want, or whatever we want to give you. Another thing that I do in the dash state in memory is we have a dash state, and then we go into the neutral state, which puts you in a 0.2 second like stillness state where like you can't move at all unless you're colliding with another object. But we'll also save that for another day. Imagine if you were a popular streamer and had this with no cooldown. Yeah, I would probably replace it, you know, as soon as possible. But yeah, I mean, right now, if you want to spam it, yeah, I actually might even get rid of it. It's not like that good of a sound. I should probably add better sounds to the stream. All right. That's all we really need for the dash state at the moment. So let's go into all of our states and make sure that we can enter the dash state. So if there's dash input, and there's one more thing that we need to do. Right now we're setting it to, actually, yeah, this works. This actually is not a problem. Okay, so let's go into the idle technically it could only happen in like move, fall, or jump, because if we were to ever move in the idle state, we would immediately dash. But I'll keep it. Because if you can still dash in the idle state if you're not pressing anything, it would just grab whatever our last direction was. So we actually do need to save what the player's we need to check for the player's last input. I don't know why I was struggling to say that. But we don't have anything for that yet. Let me see how I did it before. Just curious. Do I have a last input? Let me see. Oh wait, this is the same project. Move input, start, gravity. Let me see. Find in files. Where is? Oh. Player last direction is equal to vector2.right. So yeah, we could check for last direction. This is in player movement in the state script. So yeah, we could do this. Just grab the last direction. Yeah. Alright, so let's go back into our climb state, or sorry, our dash state, and we'll say if movement and you know what I'll do? I'll actually grab we're gonna create a dash direction variable. So we'll say dash direction is equal to vector2.0, and we'll say here if player dot movement input does not equal vector2.0. We'll run this. Else, player dot velocity, if I can spell, is equal to player dot last input, or no, last direction times dash speed. And this is actually saved in our state, right? Yeah, so we'll actually grab this from our states here. So we'll say, oh, actually, it's kind of hard to calculate if we're putting it in the state itself, because every state's gonna have a different value. Unless we set it here, so we could say player.lastDirection is equal to whatever our direction was. It also can't be determined by. I remember I said this yesterday, where I said it would be based on the player's velocity, but it would also still be dependent on the player's movement. On the player's input. We could. Trying to think. Yeah, I'm just gonna create the variable here. So on a player input, you create a var and call it player, or no, last direction is equal to vector2.0. And in our movement here, I'm gonna say player dot last direction dot x is equal to player movement dot x. Player dot movement Oh my god. Movement input dot x. Okay, and this is dot x, and this is capital. Player dot last direction dot x is equal to player dot movement underscore input dot x. Okay. Actually, we also want to make sure that this is not equal to 0. So if player dot input dot movement input dot x does not equal 0, then this. And by default, we want to set this to some value, so I'm going to set this to right because usually that's what our direction is. So last direction is vector2.right. And in our state here, dot x is equal to movement input dot x. Okay, perfect. We did all of that because we want our x. If our movement input does not equal x, we want to make sure that our last direction dot x is something. So actually, what we're gonna want to do here is say if movement. Oh wait, play movement. This is in dash. Whoops, we want to be in dash. So in enter state, if movement input does not equal vector2.0, player velocity is equal to our movement input times our dash speed. Otherwise, our player velocity is going to equal our player last direction times our dash speed, which is going to be left or right. And then that's it. And then when we're not dashing, we go back into the false state. We also want to make sure at this point that we start our timer. So we're going to say, we'll call this dash duration. Grab this up here, say at on ready dash duration underscore timer is equal to, and I'm forgetting to put a bar here. Start the timer here. Dash duration timer dot start dash duration. Just make sure that this is set to one shot. By default, it's 0.2. And that should be it. Let's see. Which state do we handle first? I don't think we actually checked for any state yet. So let's go into the move state. If player dot dash input return states dot dash, and let's just do this for every state. So move state, idle state. Let me just make sure it's called dash. Yeah, move, fall, jump, slide, climb. Yeah, almost every state is going. You're going to be able to dash into. Another thing that we need to make sure of is to check if dash input and can dash. Best time to do it is when you're talking. Yeah, definitely. It's so funny. Okay. Yeah, there we go. So right now we have infinite dashes. And it doesn't look so pretty because, you know, well, there are no animations and it's not limited by anything. What we're going to want to do is check if we can dash. So let's go back. Oh man, I should have... here, we're going to have to add and can dash. Did we add this already? Dash input. Yeah, I wonder if I should put it here. Yeah, we'll put it in the player, whatever. So we're gonna do whatever. We'll call it mechanics. We'll call it var can dash. And by default, we'll set it to true. And let's just add this everywhere. And can dash. Okay, and we want to make sure that on the entrance of some of these states that we can actually... Oh my god, I'm dumb. We want to do player.candash. Okay. Okay, and let's write some other functions called enter state, and we'll say player.candash is equal to true. In our movement state, we need one. Func enter state. Player.candash. In our fall state, oh, it's only in the idle and move state actually. And then when we exit our dash state, we want to make sure player.candash is equal to false. Moment of truth. Wait, I set our climb button and our dash button to the same thing, it seems. Yeah, I did. Alright, there are some bugs with this. Yeah, let's make sure. I do need to make sure if we spam the same buttons on top of each other that like there's no inconsistency in like the player's velocity. But give me 1 second, I'm gonna use the bathroom. Is it going to climb every surface? So I mean, that's something that we could figure out later. In the current version of the game, you can climb every surface besides like spikes, obviously. Or every surface that you can collide with, you can climb, basically. Um, I did code something where like it would manipulate the friction. So like if you were to try to climb like a slime wall, the friction, you could just manipulate whatever. We don't have friction yet, but we could add friction to the climb state or into the slide state. We have one on the slide state. So basically we would just set the slide friction to 1 and then the player would fall just as fast. But yeah, not a concern just yet. Let's try to figure out what's going on with our buttons here. Input map. So climb is C, dash is F or X. How is it that I'm going into the dash state from pressing C? I must have messed up here. Oh yeah. We put climb here instead of dash. But it does bring an issue. Like right now, or maybe it's not a problem. Alright, let me see. Yeah, it wouldn't be a problem actually. I just realized because when you enter the dash state, it resets your velocity anyway, so it's not like you can stack both your climb and your dash. But the dash does seem a little too powerful at the moment. Wonder why. Oh, it's because we don't have a neutral state yet. So like we're going up, and then your velocity doesn't reset. So what we could do here, in our dash state on the exit state, is we just want to make sure velocity is set back to 0. Player dot velocity is equal to vector2.0. And I mean, it's pretty subjective. Like personally, I like the idea of resetting velocity, but some people don't. Some people do. It's subjective, really. So what we'll do here for people that want to like mess with this code is we're gonna set we'll say keep momentum or something, you know. We'll have a variable called keep momentum. Momentum is equal to false by default, and if keep momentum if not keep momentum, do that, pass. And actually, you know, I feel like people will like the idea of not keeping them. We'll set it to true by default. And if not keep momentum, if player dot velocity, yeah, okay. But I will set it to false right now, so that we can make sure it works. No, we already know it works, but I'm gonna test it out anyway. Okay, moment of truth. I mean, it's the same thing. Okay, and if I set this to true, there we go. Oh. Okay, so the issue with keeping momentum, there's one issue with this, and that's if there's no input from the player, we set the velocity back to 0. So you can see once you dash, you just fall straight down. So we're gonna have to figure out what we want to do there. We can create two So because I'm replicating memory, I'm probably not going to do this. So by default, we're actually going to. I'm sorry, guys. The reason. You know what? Give me a day, and I'll try to figure out what to do about it. Because what we could do instead is have 2 velocity values. And actually, this is something that kind of messes us up with Godot 4. Because in Godot 3, basically, you could just use move and slide on have 2 different velocity values and have one of them manipulate the player. Maybe there is a way to do it with kinematic bodies, or character bodies is what they're called now. Let me see. Move and slide. Guess, because move and slide works differently now. Wait, what the hell? Move and yeah, so what we would do is we would have to create like a momentum variable on top of velocity, so it'd be like a sub variable that we would always have to like keep track of, which would be fine, but that wasn't the intention of the game originally, so we'll have to see. For now, I'm going to remove that. We'll just set this to false, call it a day. If people find, or like, I guess on the if people on stream tell me that they want something, or maybe if people on the YouTube channel make a request, we can make something happen. But yeah, that is it for today's stream. Tomorrow I'll do animations and tilemaps. Let's see who is available, or we also might even work on more states. Like the neutral state might be a good idea to work on or something. Alright, I will see you guys. Till next time. We're going to be raiding Irish John. Bye-bye.
Practical NPC, thank you. How are you doing? Thank you for the raid. How was your stream? What will be up to?